Hello. In this video, we're going to continue our study of functions and transformations, but we're going to look at function operations as transformations. Let me show you what I'm talking about. Let's calculate the following. We have f of x and we have g of x. And f of x is 2x minus 1, g of x is negative x plus 3. Let's calculate f of 1 plus g of 1, and f of 0, g of 0, f of 2, g of 2. So again, if you remember how do we do these, it just means we find f of 0, then we find g of 0, and then we add them together. So this first one's going to be negative 1 plus 3, which is 2. Then we're going to get 1 plus 2, which is 3. And here we'll get 2 times 2 is 4, minus 1 is 3. Plus 1 is 4. All right, so we did these three values. We got these three values. And now we're going to take these points and we're going to make a graph and see what we notice. So here you have a graph of f of x being 2x minus 1. We can see the slope of 2 and the intercept way down there of minus 1. Here's our g of x, which has a negative slope with a y-intercept of 3. And we have our points 1, 2, 3. Now I'm just going to go ahead and connect the dots here. And we have our nice new cool graph. And this graph is created by taking f of x and g of x and adding them together. You can almost visualize this by looking at the points. Let's say we're going to look right here. So I'll try to circle up this location here. This is x equals 1. So we can see f of x was equal to 1. That's a y value of 1. And g of x was equal to 2. You see here the value of 2. And 1 plus 2 is 3, which is the value up there. So f of x and g of x, when we added them together, lots of things happened, right? We got a nice new graph, which looks pretty cool, this black graph. We could think of it as adding up the y values and making this new, bigger graph. And in particular, what's so cool about this is it's a transformation that's different from what we've done before. It's not a stretch, it's not a translation, it's not a reflection. It's a new thing by taking one graph, f of x, and another graph, g of x, and adding them together, we get this cool new graph. But because both fx and g of x are lines, the new graph just ends up being a line. And if you really wanted to, we could have done the algebra, right? F of x plus g of x would have been 2x minus 1 plus negative x plus 3. And so that would have given us down here an equation x plus 2. And so we could have just come up with the equation with algebra, and then it kind of removes the mystery and the intrigue of this. So what I actually want to do is look at some different functions where we don't have an equation, and where we have to follow this idea of finding the y values, adding them together to get the new y value, but not having an underlying equation to work with. So here we have f of x in red and g of x in blue. So here's fx, here's g of x. And we want to graph f plus g. Now, there's no f to plug into, there's no g to plug into, so we're going to have to use, like we said, some kind of method like before. And the easiest thing I would say is to make a nice table. So I'm going to go ahead and make a table with x and fx. And I'm going to extend that table to include g of x. And then at the very end, we'll have f plus g of x. So let's start making some x values. We'll start right over here at negative 3. So negative 3, negative 2, negative 1, 0, 1, 2, and 3. All right, so what is fx? Well, at negative 3, there's nothing for the fx. This is undefined. This is just, I'll just put a question mark here. It's kind of like not applicable, right? There's nothing over there. But at negative 2, we've got a value right there of 0. Then at negative 1, we have 1, then 2, 1, 1, 1. Okay, so we take these points right here from fx, and we transfer them over into the table. All right, let's go ahead and do g of x. Well, g of x at negative 3 has a value. It's going to be negative 2, and then negative 2, negative 2, negative 2. But then at 1, we get negative 1. And then 0. But then at 3, there's no graph. It looks like g of x just stops right there. So that means that here, it's kind of like question mark. It's kind of like not applicable. Now let's go ahead and add each one of these. Well, how would you add a question mark to negative 2 or not applicable to negative 2? It seems like those don't really add together. So in fact, here at negative 3, this is undefined. We can't really add a blank or like nothing. Like it's not a 0. The next one's 0. We can add 0 plus negative 2. That's negative 2. Or 1 plus negative 2 is negative 1. This is 0. This is 0. This is 1. Right? 1 plus 0 we can add. But 1 plus a blank, plus a question mark, plus not existing, this unfortunately is undefined. So there we go. At 3, we kind of notice that this point is undefined. And at negative 3, this point's undefined. But the rest of the graph is good. So let's go ahead and do that in green. We're going to take this table and we'll graph it. Negative 2, we have a y value of 2. Negative 1 is 1. 0 is 0. 1 is 0. And 2 is 1. So this green graph here represents f plus g of x. Now I find this just super fascinating. One thing that's interesting, of course, is that we have to have both graphs existing to have f plus g. You notice that since there's no red graph over here, we have no green graph. And there's no blue graph over here, so we have no green graph. We can only graph the overlap. So you can only graph the overlap. In other words, f, x, and gx must exist. fx and gx must exist. So I find that interesting. I also just think the shape is pretty cool, right? It's kind of like this, and then flat, and then goes up again. And it's just fun. It's interesting to graph f plus g. And as long as we make a table, we're good to go. Again, how are we making this table? The important thing here is that we are adding here. We are adding the y values. So we are adding y values. But if you notice, the x value remains the same. So we're adding the y values, but the x values here, x values stay the same. We don't add the x values or something like that. We just make a table, add the y values. So let's go ahead and practice this with subtraction. So I'd like you to go ahead and set up a table, see if you can graph f of x minus g of x. Remember, we're going to keep the x values the same. We're going to subtract the y values, and we only do it where both graphs exist. All right, so assuming you gave that a try, we have f, we have g, and we have f minus g. So I'm just going to skip off the negative 3 and go right to the negative 2, negative 1, 0, 1, and 2. fx is going to be 0, 1, 2, 1, 1. G of x is negative 2, negative 2, negative 2, negative 1, 0. Now to subtract them, 0, subtract negative 2 is going to be 2. 1 subtract negative 2 is actually 3. Then we're going to get 4, and then 2, and then 1. Okay, so we have 2, 3. Oh, it's a little bit off our graph. Maybe I'll try to move this a little bit. All right. So we have negative 2 and 2, negative 1 and 3, 1 and 0 and 4 up here. 3, 4. And then 1 and 2. Oh, and then the last one got cut off, but we had 2 and 1. 2 and 1. So this would be our new graph. And again, this is fx minus g of x. All right, let's graph f of x times g of x. So again, pause the video and See if you can create that table, and then go ahead and create the graph. All right, so assuming you give this a try, let's move this over here, make some space. So we have x, fx, gx, and then f times g, -2, -1, 0, 1, and 2. Fx has values 0, 1, 2, 1, 1. G of x is -2, -2, -2, -1, and 0. Well, 0 times anything is 0. 1 times 2 is -2, -4, -1, and 0. So if we move this up a little bit here, we're going to have -2 and 0, -1, -2, 0, -4, 1, -1, and 2 and 0. So here's our graph, something like this. All right. Now one more for good measure. Let's go ahead and graph f divided by g of x. So this is really tricky. You have to do division on this one. So again, pause the video and give it a try. Okay, so again, we have x, fx, gx, and f divided by g. So the f values are right here, 0, 1, 2, 1, 1, -2, -2, -2, -1, and 0. So 0 divided by anything is 0. This would be a -0.5, -1, -1, and then undefined because we can't divide by 0. So this is a bit weird. It starts here, then here, then here, then here, and then undefined. Now, we'll talk about this more in another lesson, but if you got just this basic idea here, this is pretty good. Technically, this point is actually going to create an asymptote, and the graph would go down like this. But that's a little bit of an extension, and what I probably would do on a quiz or on an exam is I maybe wouldn't have this divide by 0 part. I'd maybe chop it right there and just ask you to do this portion. But if you're curious, that's what happens in this graph when we go really close here, right? We can see it would be easier if we maybe added in a point like 1.5, an extra x value. So if we added in an extra x value, f of x we'd see as 1, but g of x would be -0.5, and 1 divided by -0.5 would be -2. So we can see it's going to get more and more negative as we go down, and so that's going to create that asymptote. Now I want to talk a little bit about domain and range. So jumping back to this example, we can see that we have lines that have arrows on them. So the domain for this black graph would be all real numbers. If you remember the domain, we could stay as all real numbers, XER. But I want a different way of writing this, and I want to focus a little bit on interval notation. So let's just take a quick step here. If I said XER, what that means is I have a graph, and it takes on all real numbers. But another way of writing that is to say that we have the domain -infinity to infinity. This is my domain. And what I mean by that is it goes all the way left to -infinity, all the way right to +infinity, and we put round brackets because infinity is like a number, not like an actual value you can attain. Same thing for the range. If we do interval notation, because it goes down all the way and up all the way, we put -infinity to infinity. So let's look at this graph that we had. What would be the domain and range of the green graph? Well, let's make a little bit of space here. The domain and range of f, of g, of f plus g. Let's start with fx. The domain for fx starts at -2, and let's pretend there's an arrow on that right side. So the domain would be -2 to infinity, because the graph continues on to the right, and it starts at -2. Because it's starting there, we include a square bracket, not a round bracket. Now just looking back up, what's the range of this graph? Well, it looks like it goes from a low value of 0 up to a high point of 2. So the range would be 0 to 2. So the range would be 0 to 2. And we use square brackets again because we include those upper and lower values. All right, so let's look at the green graph, or sorry, the blue graph. Let's look at g of x. What would be the domain and range for g of x? Domain and range. Well, again, assuming that there was an arrow on this side of the graph, it goes all the way to negative infinity, but then it stops at 2. And the range, it goes all the way down to negative 2. That's the lowest value, and 0 would be the highest value. Now for the last one, I'd encourage you to pause the video and look at the green graph. See if you can write the domain and range for the green graph. All right, I'm running out of space here, but let's try to sneak the domain in right here. The graph goes from negative 2 to 2. So the domain is minus 2 to 2. And the range goes from minus 2 up to a high point of 1. So negative 2 to 1 with square brackets. Okay, so we need a little bit more practice on this domain and range stuff. So go ahead here on the black graph, f of x minus g of x. We did this earlier. See if you can write down the domain and range. Okay, so the domain will be minus 2 to 2. And the range is from 1 to 4. The domain goes from left to right, so lowest value of negative 2, highest value of 2. The range goes from bottom to top, so lowest value of 1, highest value of 4. Again, try to do the domain and range for this f times g graph, the black one. See what you come up with. Okay, so for domain, you should have minus 2 to 2. And for range, we have minus 4 to 0. All right, so now just on that last one, the division, go ahead and pause the video and see if you can get the domain and range. All right, so this one's definitely a little challenging. For the domain, it looks like we start at negative 2. And we go all the way to 2, but we don't get to include it because of that divide by 0 or that asymptote, so we have to put a round bracket. For the range, we go all the way down to negative infinity, and we come back and we stop at 0. Again, we get to include 0 because it happens, but negative infinity is a concept, so it needs a round bracket. Here we have a round bracket because we don't get to 2, but we get a square bracket because we do get to include negative 2. Now just a little bit more practice on this domain and range stuff. If fx has a domain of negative 3 to 6 and a range of 2 to 9, could we find the domain and range of f inverse? Well, yeah, if you remember for f inverse, we swap x and y. So if we were to swap x and y, we would swap the domain and range. So for f inverse, the domain would be simply 2 to 9. The domain becomes the range, and the range becomes the domain. So again, it's crucial here, we're not swapping the order of the points in those interval notation. We're simply swapping the whole interval itself. Because if the old graph used to have x values that were from negative 3 to 6, the inverse will have x values that are between 2 and 9, because the x values will become the y values, and the y values will become the x values. Okay, what if we had a domain of negative 3 to 6, and instead of doing the inverse, we did 3 times fx. We did a vertical stretch. Go ahead and pause the video and see if you can determine what that domain will be. All right, so the 3 affects the y values. So this affects the y values. And the y values get multiplied by 3. The y values are the range. So 2 times 3 is 6. 9 times 3 is 27. So we should have a domain from minus 3 to 6 and a range of 6 to 27. All right, let's do a really tough one. Let's add all these transformations and see if we can determine the new domain and range. Pause the video and give it a try. Okay, so for the domain, that's going to be the x values. So let's look at the negative 3. We're going to divide that by 3 because of this 3. And then we're going to subtract 1. That's going to be negative 1 minus 1 is 2. And then the 6 also has to get divided by 3 minus 1. It's going to be 2 minus 1, which is 1. So the new domain is negative 2 to 1. Right? Both of these numbers in this interval are x values, so you apply the x transformations to both of them. Now for the y values, we're talking about the range. So there's a 4 and a negative 6. So we take our 2, we multiply by 4, and we subtract 6. That's going to give us 2. We take our 9, multiply by 4, minus 6. That's going to give us 30. So the new range will be 2 to 30. Okay, so let's take some notes on this. We learned today about adding, or really I should say, we learned about graphing function operations. And the basic idea here is if you have y equals fx plus gx, and you have to graph it, the basic approach is you add y values. And if it was subtract, you subtract the y values. The best way to do it is in a table with x, fx, gx, and then your final thing, maybe f plus g of x. But, and this is crucial to note, both of these have to exist to give you this one. You need both. If one is missing, can't add. You can't add something that isn't there. And so you have to have both f and g, you have to have the overlap if you want to graph their addition or their subtraction or multiplication or division. So let's go ahead and try an example here. And just for fun, let's do fx plus gx. Let's keep it the same. So we're going to do x equals 0, 1, 2, and 4. Fx will be equal to 3, 1, 4, 7. G of x will be equal to 0, 0, and 7. And then there'll be nothing. This will be undefined. So when we add them here, go ahead and pause the video and give that a try. All right, so this will be 3, 1, 11, and undefined. So then if you were to graph it, the points would be here 0, 3, 1, 1, and 2, 11. So this is be a bit of a strange graph, but we'll make it work here. So we have 0, 3, 1, 1, and 2 and 11. 0, 3, 1, 1, and 2, 11. Now for some extra practice, you can try worksheet 11 and 11.5. Definitely you're going to want to work on your domain and range. Even a graph like this here, this blue graph, it might be worth doing even right now. What's the domain of the blue graph? It appears to be from 0 to 2. What's the range on this blue graph? It looks like the lowest value is 1 and the highest value is 11. You want to get comfortable with using interval notation and writing down domain and range if that's something you haven't done in a while. So any things to remember? You might write down that you only operate on the y values. So by operate, I mean you only add or subtract the y values. X values stay the same. Or you might want to write down any rules for interval notation. If you're having some trouble with that, you want to write down, maybe do a few examples of how interval notation works for doing domain and range. All right, hopefully you enjoyed this video, and as always, thanks for watching.